Alright, you guys, so this video is going to be on how to understand circuits, and we're going to be looking at circuits with resistors. So right away, I think you guys should pause the video right now and just record everything that's on the screen. That way we can get through this video a little bit quicker. So, okay, let's start by looking at this circuit. We have a battery that's 12 volts. And we have 5 different resistors with different ohms. So what we're going to do to find the voltage, the current, and the power at each of these resistors, we're going to start combining them. So right away, I like to label everything to keep it really clear. So let's call this resistor 1, this resistor 2, resistor 3, resistor 4, and resistor 5. Okay, generally we can start by combining resistors that are parallel first, but in this case, resistors 2 and 3 are completely separate from resistors 3 and 4, so let's look at how we can combine those. Right here, we have resistor 1, which is still the 6 ohms. Here we have resistor 2, 3, which is combined from resistors 2 and 3. And right here we have resistor 4, 5, which is combined from resistors 4 and 5. So let's calculate what the resistance is for our 2, 3 and our 4, 5. So resistors 2 and 3 are in series, and going back to the series equation, you can just add them up. So 6 ohms plus 3 ohms equals 9 ohms. And for resistors 4 and 5, you have to add them up a little bit differently by taking the inverse of 1 divided by R4 plus 1 divided by R5. So just like this. Okay? And the values we get for these are 2.25 ohms. Okay, so let's fill that in. Alright, so we've combined everything we can at this circuit right here. Let's keep combining. Okay, so right here we still have R1, which is 6 ohms. Here we have R2, 3, 4, 5. Because from the last circuit we've combined R2, 3 with R4, 5. So R2, 3 is in parallel with R4, 5. So we have to add them up that way. Okay. So just like this, we can calculate what R2, 3, 4, 5 is. And let's see, what value do we get? 1.8 ohms. All right. And now finally, we're at our last circuit. Our battery is still the 12 volts. And we have one resistor. So that's going to be Req. That's going to be the equivalent resistance. So to calculate that, R1 is in series with R2, 3, 4, 5. And even though it might not look like it, they're actually on the same wire. Even though there's a bend in the wire, don't be confused by that. So in that case, we have 6 ohms plus 1.8 ohms. So we have 7.8 ohms as our equivalent resistance. Okay, so now that we've found equivalent resistance, we can start finding the voltage, the current, and the power at each of these resistors. So you start where you end. You have to start at this last circuit right here. Okay, using Ohm's law, V equals IR, you have to ask yourself, what don't we know about this circuit? So we have the voltage, we have that it's 12 volts, we have the resistance, which we just calculated to be 7.8 ohms, but we don't have the current, we don't have the amps. So let's calculate that. If we rearrange this equation, we have that I total, because this is going to be the total current, equals V total, the total voltage, divided by Req. Okay? In that case, we have 12 volts divided by 7.8 ohms. And let's see what that equals. So we get 1.54 amps as our total current. Okay? And also, I really like to draw what's happening. So these green arrows, this is the total current going through the circuit. Okay? So now we know everything. We have the voltage, the resistance, and the current. So we can work one step back. Okay? So going back to this one, let's draw our current. So we have I total coming out of the battery. We have I total going through resistor 1. And we have I total going through resistor 2, 3, 4, 5. So this tells us we're still working with I total. Okay? And the difference between these two circuits is that the equivalent resistance has been split into two series resistors. So you have to ask yourself, what's special about resistors in series? And it's that they have the same current. So series resistors have the same current. Basically, this is what that means. Okay. And we can also see that this is true just by drawing it how we did with the green arrows. Okay, so we have the current, we have the resistance, which we calculated right here, but we don't have the voltage. So we have to figure that out. So V1 equals I1 times R1. So I1 is equal to I total, which we calculated to be 1.54 amps, times resistance 1, which is 6 ohms. Okay, and after typing that into our calculator, we get 9.23 volts. Okay, so this is V1. And we can actually go over here and fill that in. 9.23 volts. And also, we can fill in what we have for I1 from our rule. So, like we just said, I1 is 1.54 amps. Okay. So now that we have those, let's figure out what the voltage is at resistor 2, 3, 4, 5. And we're going to do this really similarly, just like this. So I2, 3, 4, 5 is equal to I total. So 1.54 amps times the resistance at that resistor, which we calculated to be 1.8 ohms. Okay, and when we type that into our calculator, we should get 2.77 volts. Okay, and now this is something really cool. So we just calculated the voltage at each of these resistors, and to make sure we've done the problem right, the voltage from before was at this resistor will equal V1 plus V2, 3, 4, 5. So let's try that. V1 was 9.23 volts plus V2, 3, 4, 5, which was 2.77 volts, which will equal 12 volts. Alright, so that's how we know we've done the problem right. If you get a different answer, you know you made a mistake somewhere, and you can go back and check, but we have this right. So now we have everything at this circuit. So we can go one circuit back. Okay? Let's start by drawing the circuit. So here we have I total. Here we have a split. So at this junction right here, the current splits. So I total splits into I2, 3 and into I4, 5. Okay. And if we keep drawing it, we see that these two will add up to I total. Okay. Just like that. So in that case, we see that I total equals I2, 3 plus I4, 5. Okay? So now let's ask yourself, what's the difference between this circuit right here and this circuit right here? And the difference is that R2, 3, 4, 5 has split into two parallel resistors, R2, 3 and R4, 5. So what is special about resistors that are parallel to each other? So parallel resistors have the same voltage. So the voltage at R2, 3, 4, 5, which we calculated to be 2.77, will be the same as the voltage at resistor 2, 3 and the resistor at 4, 5. So now we have both of these rules right here, and we can start solving. So we know the voltage at those two resistors, and we know the resistance to be 9 and 2.25 ohms, but we don't know the current. So let's calculate our I2, 3 to be V2, 3 divided by R2, 3. Okay, so 2.77 volts divided by 9 ohms equals 0.308 amps. Okay, and let's do the same thing for the other resistor. I4, 5 equals V4, 5 divided by R4, 5. So 2.77 volts divided by, what's the resistance? 2.25 ohms. Okay, so after typing that in, we get 1.231 amps. Okay, and now let's just make sure we're doing it right. So I total, what did we calculate that to be? 1.54 amps. And that should equal 0.308 plus 1.231 amps. And it does. So this is what I total equals. So we know we've calculated the correct currents. So now we have everything at this circuit. We have the voltages from our rule. We just calculated the current and we found resistance earlier. So we can go one step back. So now we have to ask ourselves, what's the difference between this circuit and this circuit? And it's that R2, 3 has split into two series resistors. Okay, and also R4, 5 is split into two parallel resistors. So let's start with the series ones. So in series, resistors have the same current. So I2, 3 equals I2, which equals I3. So now we have the current and we have these resistances, but we don't have the voltage. So let's calculate that. V2 equals I2 times R2. Okay, so what did we say I2, 3 was. So we calculated it to be 0.308 amps. 0.308 amps times R2, which is 6 ohms. So what do we get when we calculate that? We get 1.846 volts. Okay, so now this is something we need. So V2 is 1.846. 1.846 volts. And also we have I2 from our rule, which is just 0.308, 0.308 amps. Okay, and we also have I3. It's going to be the same thing, 0.308 amps. Okay, so let's calculate V3. It's going to be I3 times R3, which equals 0.308 amps times 3 ohms. So let's see what we get. We get 0.9 0.923 volts. Okay, so we can also fill that in. 0.923 volts. Okay, good. So now we know everything at this part right here. So let's calculate the parallel part. So resistors in parallel have the same voltage. So that tells us V4, 5 will equal V4, which equals V5. So what did we calculate for V4, 5? Let's see. Earlier, we calculated that to be 2.77 volts. Okay, so that tells us what V4 is and what V5 is. So we can fill these in here. And we know the resistance at each of these resistors. We know the voltage, but we don't know the current. So let's calculate that. I4 equals V4 divided by R4. I5 equals V5 divided by R5. Okay, so 2.77 volts divided by 4.5 ohms. It's going to be the same thing for I5. Okay, so let's see, what do we get when we calculate that? We get 0.615 amps. Okay, and now we can use these, we can fill these in. Just like this. Okay, so now we have all the voltages and all the currents. Let's see if all this makes sense. So like we did for these, let's just draw currents quick. We have I total, and it splits into I2, 3, which equals I2 and which equals I3. And here we have I4, 5, I4, 5, and now this splits into I4 and I5. And we can see that these will add together again to equal I4, 5. So it does make sense. That makes sense. Also, using our rule here, we can do the same thing for these. So I4, 5 will equal I4 plus I5. So we calculated it to be 0.615 plus 0.615. And what was I4 comma 5? It was this value right here. So that does make sense. Okay. And lastly, let's check ourselves right here. So V2 comma 3 will equal V2 plus V3. So what did we say V2 comma 3 was? Okay, it was from our rule back here of 2.77 volts. So 2.77 volts should equal 1.846 plus 0.923. So let's see if that holds true. 1.846 plus 0.923. Yes, that's true. So that it does equal 2.77 volts. Okay, so we've done everything right. We have all the voltages and all the currents. Now all that's left is to calculate the power. And for that, we're going to use this equation right here. So I like to calculate power last after we find all the voltages and all the currents. So P1, after typing that into this equation, is going to be 14.2 watts. P2 is 0.57 watts. P3 is 0.28 watts. And P4 and P5 are both 1.7 watts. Alright, so now we have everything. That is how you solve this problem. Thank you guys for watching.